Welcome back to Bitcoin Season 2. I'm Charlie Spears with Blockspace Media. Bitcoin Season 2 is about new ideas and new faces on the oldest blockchain, Bitcoin. We talk about both the degen and the technical and everything in between. And today I've met my final boss for research to try to figure out how to talk about this. I've got Misha Komarov, who has authored a paper on Bitcoin pipes, which is a scheme to emulate certain opcodes like CAT or CTV without a soft fork to Bitcoin. Make sure you check out other Blockspace Media content, Gwart Show, Mining Pod, our newsletter. Go to blockspace.media and hit our socials. But before that, a word from our sponsor, Botanix. Bitcoin Season 2 is brought to you by Botanix. Botanix Labs is pioneering a new direction for DeFi with the first EVM L2 running on Bitcoin that's built to be forward secure, decentralized, and share gas fees generated by the network with users. See the future of DeFi at Botanix, botanixlabs.xyz. Misha, welcome to
Hey.
Bitcoin Season 2. Thanks for coming on here.
Yeah, it's well, thanks for inviting.
Yeah, so first of all, I'm pretty excited to have you at our conference Op Next in Boston in a few weeks. So yeah, you're doing a workshop and presentation on this. This is pretty interesting.
Well, it is. It's look, all I'm doing these days is just going around and basically soliciting opinions and soliciting the potential criticism or maybe whatever there is on this kind of this pipes concept. So we'll see how it goes.
So let me get some background on you. I'm pretty dialed into the Bitcoin developer community, at least more so than your average pleb miner. But to me, you kind of came out of nowhere, and I'm a little familiar with the Nil Foundation. But give me some extra context on your background and where you come from and how you end up, I think, publishing one of the more interesting papers on Bitcoin right now. Where do you come from?
Okay, it's where does this whole thing come from?
Yeah.
All right. Well, I come from quite long time ago. I would say it's if you do remember such a thing, back in 2013, there was this thing called BitMessage. Remember such a thing? Yeah.
I've heard the name before, but yeah.
Yeah, basically, it's the attempt to try to embed but early experiments about how do you embed something human readable into whatever you usually hash as a replication packet in Bitcoin. It's if, for example, you start just writing human readable messages in there, right? Kind of Bitcoin or Messenger, back from 2013. So CPP implementation of it, if you still can find it on the internet somewhere, these hands, all right? So that's the thing. After that, it's been quite a long journey. I kind of was all around the place, in crypto in general, I would say. It's starting from, doing stuff with Dan Larimer, all around Stimit, BitShares, all the stuff. Pretty fascinating. It's pretty fascinating in terms of architecture. Does it work? In some cases, yes. In some cases, not. Whatever. So, I don't know. Brum Cohen, goddamn, it's VDF with Chia guys, Filecoin stuff. I don't know, you name it, Nil Foundation, LIDA, Mina guys,
the whole crypto, yeah,
just all over the place. So I guess in the end of the day, where I came from in terms of why I came back is basically hey, why don't we try to apply everything we developed all around the place? Why don't we try to apply it back to Bitcoin, considering that it has become much more interesting these days, I would say, because people are not that scared because of 2021 shit anymore. So everybody's a little bit more open to new ideas, a little bit more open to experimentation. So why not? It's
yeah. So you're back, baby, and you're under a lot of your work focuses under a company or initiative called Allokinit. Explain this to me. You tried to explain the nomenclature here. Where's this come from?
Okay, well, it's this whole Allokinit initiative is basically what we have started about half a year ago, after we realized that we gave birth to too many things it's in Nil, the Nil Foundation. It was basically a cryptography research and development firm, and now it focuses on Ethereum, but whatever, doesn't matter. So basically we were okay, well, we gave birth to too many things in there. Like, so we got to try to maybe like, all of those like are very research intensive, like heavy things. So each of them is basically like a separate project. So we're like, okay, well, let's start this little research organization, which will be like, just pushing forward this like, research around like different, I don't know, different areas, right? Like, and bootstrapping it's like what makes sense to be bootstrapped like right now in terms of, in terms of what the stack is applicable to, is like what the problem we see can be solved and everything. So it's like this kind of thing. It's a research fund, all right? So yes, it's called allocated because it's basically the variation over the default constructor in Objective-C, if somebody remembers such a language. So
and
like,
and and this will preface this will kind of contextualize this conversation because I'm not familiar with the default constructor in C, and that'll let me like kind of disclaim here. Like I feel like I bit off way more than I can chew trying to be one of the first people to talk to you about through pipes because but I'm not afraid to look dumb, and I even though I may not understand how this works, maybe like a listener can like get a little incrementally further, or at least it can like perhaps like broadcast more of what you're working on. And just I'm not and for the listener, I am not versed in the even some of the basic foundational concepts in cryptography. I have a little more technical understanding of Bitcoin than the average person, but um we're just going to jump right into this. And so Misha, before we talk about pipes, I think you actually prefaced the both the pipes white paper and your blog
yeah,
very well, where you actually just begin with like, what are opcodes and covenants? This is something
yeah.
I understand. Just start by explaining what opcodes are, and then how does an opcode produce a covenant?
Okay, let's go for it. So basically, let's say it this way: it's like all of these, like protocols. It's like, for example, like again, like Bitcoin or like something which like got inherited from it. It's like all of them. They have these conditions on why like certain transaction got to be like accepted or not, right? It's like you can just pull it right in without like literally, it's like no, without any literally like conditions or something. There were protocols with such an architecture back in 2016, 2017. Like I've done some of them myself as well, but whatever. So like designed, okay, well not really done. But anyway, so and like this, kind of conditions on why certain transactions should be applied, should be like, included in the protocol, like in the next replication packet, like for example, should be mined in the next block, right? It's like it's basically defined by, it's like it can be a little bit parameterized. It can be, it's like the behavior of it can be a little bit more, I don't know, like parametric, like programmable, right? So you need to virtualize some kind of executor which will define these conditions if a certain transaction can be like, put into the protocol or like not into the protocol commit log or not. So basically for this, you need some virtualized executor. Like for Bitcoin, for example, that is, like this pretty trivial, pretty like simple, but, kind of, well, enough for certain purposes, like Bitcoin script, which is basically, well, consists of like whatever, like several like opcodes, and, well, quite a lot of them actually. But anyway, so each of them defines behavior. It's like each of them defines behavior over the transaction which comes in, and yeah, so combination of them can define pretty complicated behavior. Well, maybe not that complicated as like somewhere else, but anyway, it's like it's enough for most of the purposes.
And so these opcodes, they work within Bitcoin script. They basically produce valid transaction that you can sign. And there is this discussion now, and I'm a huge proponent of a, a mechanism called covenants within
Yeah.
transactions. And this is by many there's a this is a technique by many who say this allows us to make Bitcoin much more expressive
Yeah.
as well as scalable. What is a covenant though?
Well, okay. It's like the covenant. It's like the covenant. The covenant basically, let's say this way, it's like covenants are being usually called those particular like whatever opcodes or like certain ways to define how a certain transaction can be basically like whatever released or like can be included in a protocol. Like again, it's like the covenants is like a little bit more generic than, just like, whatever, like set of opcodes or something, because sometimes you can define like a covenant with like a bunch of opcodes. I don't know, you can define a covenant with like, for example, off the protocol, like at all. There are like several tricks how to do that. Like this whole pipes thing is one of those tricks of how to define these covenants, like off the protocol at all. So it's a condition how you can include your transaction into the protocol, how you can spend your bitcoins basically. So it's kind of a little bit of more general notion of what the hell is this.
So, you've written this proposal for Bitcoin pipes,
Yes.
and I think for the listener, this is a proposal, and I've intuited somewhere that I think you're working on an implementation, and we'll get to that. But this is an idea which you are currently working on actually implementing.
Yeah.
So we don't have like an actual demonstration of what it like
Not
of
yet.
working. Not yet. So we'll
Not
come
yet.
back to that at the end. But let's just get right to it. It's been too long. Explain to me, what is a Bitcoin pipe?
Okay, let's go for it. So it's like you want, like, for certain cases, like you want to define complicated behavior for a transaction to go through, basically, right? So how do you like define this complicated behavior? Like again, you do it with the currently existing opcodes, and or you try to add new opcodes which enable you to do more complicated things within the smaller amount of basically block space. So it's like, so you don't need to like fill in the replication packet with like megabytes and like terabytes, or like opcodes, like very simple ones. You can like do something which is very like small, efficient with just one. For example, opmule, like a multiplication opcode, right? So that's like something which kind of was disabled in Bitcoin like in the early days. Well, in the same time, like emulating that with just additions and subtractions, I mean, dude, nah, just nah. So for complicated cases, like for example, I don't know, ZKP's verification of Bitcoin. Okay, that's like kind of also a pretty hot topic, like for the last couple of years at least. And for this kind of uh, for this kind of tricks, for this kind of operations, you need to have like multiplication of codes. You need to have like, some whatever, like maybe additional hashing of codes. I don't know. Like, all right. You need to have people are pushing this concatenation of code, which is very, very, arguable if it's needed or not. Like people are like literally fighting about this.
Yeah.
I bet that, guys at your conference, like in November, it's gonna be a complete shit show about this. Everybody's gonna be fighting with each
We're
other.
gonna put everybody in the same room and have them at least talk. They haven't
Yeah.
actually. There's not been a lot of like cross domain discussion in a while, so we're just gonna hope that
Yeah. I
it's
mean,
productive.
it's like
Yeah.
it's like it's like get a couple of ambulances, like waiting outside of the conference venue, right? Just in case.
Yeah, and free drinks later to accelerate the conversation. So that kind of thing. Yeah,
For those who are still standing to
exactly.
not to, yeah. All right. So, and like for complicated cases, like for example, ZKP verification of Bitcoin, it's like you gotta introduce new opcodes. This is like complicated, right? I mean, just socially complicated at this point because I mean, dude, you gotta like walk around like every miner like on Earth, right? Try to convince them about this. It's just too large of a task to accomplish, I would say. So let's say this way: it's like some people are still like pushing for it. Some people are like, it's never gonna make it and everything. Like we just gotta go with whatever we have, and it's all about how do you get this more computational like expressivity without accomplishing this kind of like socially complicated thing. So basically, so yeah, that's like what is that? That's like the purpose of introducing Bitcoin pipes. All right, it's like not to have like a need to accomplish this, like walk around all the miners on Earth and like try to convince them, guys, please, like, hey, please, all right. So
So we can emulate these opcodes, therefore covenants, without a soft fork.
yes,
So
basically,
yeah,
that's the purpose of it. That's the purpose of it. So, how does that like work? Right? It's like why it's called like pipes and everything. So, pipe is basically just acronym to like polynomial inner predicate encryption. which basically is a trick, quite old. It's basically like another attempt at quite old trick, which I've seen like people posting on like Stack Overflow or something. Hey, how do I encrypt? Like for example, Bitcoin transaction with like witness encryption to introduce some time locks or something. It's like people were wondering like about this. People like wishing for this to happen. Like whatever, like I've seen 9 years ago. That was posted like 9 years ago, dude. It's a very old trick. So this like Bitcoin pipes is another attempt at doing this trick, but like a little bit maybe novel things which kind of got developed like over the last 3-4 years, I guess. Like for example, it's like, so what the hell is this about? It's basically the like function hiding multi-input predicate encryption. It's like functional encryption, right? It's like functional encryption trick which allows you to basically encrypt your private key and to execute some predicate, to execute some computation over this private key, predefined predicate over this private key during the decryption. But the only thing you get out of this is like a signature done by this private key over the transaction data you have put through this predicate. If computation you are proposing to do, like, or like you have done already somewhere and kind of just provided proof of that is valid or not. So it's this kind of trick. And it's like you basically either get the signed Bitcoin transaction with the private key, which you never know, or you don't get it at all. And like in the same time, this kind of like compute over encrypted element, like compute over secret element, something like this.
Yeah, and I'm gonna probably try to put this in my own words, probably technically inaccurately, but maybe it helps get the point across. You basically uh, coordinate, you set up with the other participants in this transaction, and you encrypt all of decrypt the private keys into a pipe and post that or inscribe that data to Bitcoin, which then can be read to
Yeah.
produce valid transactions, or decrypted to produce valid
Yep.
transactions. So if there's an ordinals degen who made it 17 minutes into
Yeah.
this conversation, they don't know anything
Yeah.
about cryptography. This is very similar. This is, instead of a JPEG, it is an encrypted,
Ciphertext.
yeah, a
Ciphertext.
cipherpass, which is really interesting. I guess my first introduction to functional encryption, because I'd not heard of this, was I think when Jeremy Rubin mentioned something about this a while ago. Uh, is this at all related to his his functional encryption covenants that he talked about like a while ago?
I mean, it's like, as I said, there were several attempts to like talk about similar things again, like even 9 years ago. So of course, I read that write up, and like it's kind of describes in general words, maybe something which kind of pre, like it's like prepends this, or like precursors this. Maybe, okay, yes, that is true. It's like I read this paper. Yeah, I mean, again, it's like this is a very old trick. It's like
Yeah,
I've seen people talking about this, like encrypting Bitcoin transactions, or like encrypting pre-signed Bitcoin transactions, or
yeah,
like signed Bitcoin transactions, like during decryption on Stack Overflow, like posts from 9 years ago.
yeah.
So that's almost like the oldest trick in the book. Attempt to make the oldest trick in the book like a practical one. So
Okay, so what do you think we talk about next? This relies on, is it placeholder proofs?
yeah,
Um, do we talk about placeholder proofs? Do we talk about setting up the pipe? Which of these things do you think is the best way to talk about this next?
I mean, we can go through both of these. I guess it's like I'll try to make it sound fun. All right, so
Okay, thank you.
all right. So what the hell are these placeholder proofs and everything, right? So these placeholder proofs is basically it's proofs of a Blonkish alike proof system over LPC commitment scheme, like hash-based commitment scheme, which is, well, again, it's like you can do like over KCG and everything, but anyway, so it's a Blonkish proof system we've designed back in nil back in 2021. It's like it's somewhat similar to what Plonky 2 is. I mean, I guess it's just Plonky 2 went public with the similar concept a little bit earlier than we did, so maybe. So that's the thing. It's, well, again, just the proof system I used because I know it the best, because like I was at the very inception of it, and like I kind of, like we did all the implementation, we used it across all the projects like we built with nil and like everything. And so that's, just an example. Like formally speaking, these things are not tied to any particular proof system. I mean, like you can verify Starks in there, you can verify like anything in there. Like if you do the recursion, for example, like the only limitation of which kind of proof system you can verify is if you can linearize, or like you can express its verification via quadratic equations, so it could be computed during the inner product computation, like when you try to yield the Schnorr signature of a Bitcoin transaction, right? So otherwise, like if you can't use the proof validity fact as a multiplier to the Schnorr signature, which you're kind of trying to produce, I mean, it will simply, there will be no conditions like for this. It's going to be unconditional signing for whatever you put in there, and that's kind of crap. So that's like why you gotta have this kind of like proof system verification inside a pipe, and that's like why it inherently enables basically native, but like whatever PKP's verification on Bitcoin, like just as a small little nuance, like little consequence of that. So that's what it is. So yeah.
So gotcha. So what was I going to ask? So as I was trying to wrap my head around like the placeholder proof system, which basically I was like, it's just a proof system, and
Yeah.
and in your paper you mentioned that it's pretty well positioned to be a good proof system for Bitcoin to be verified on Bitcoin, but
Yeah.
as your paper says, the problem is even this method doesn't guarantee the so-called pessimistic verification on
Yes.
Bitcoin because of commitments only check being possible.
Yes.
We have to introduce op mul, or to multiply two elements on the stack, and a larger acceptable script size, which requires a Bitcoin protocol grade soft fork. And so we would have to emulate missing covenants like cat, missing opcodes, opmul, and cat, larger script size.
Yes.
And this is what the pipe does.
There are two ways how can you verify ZK proofs on Bitcoin, right? It's like the first way, like is like using pipes. It's like you can either define ZKP verification on Bitcoin like as a part of native pipe functionality. I mean, you can basically just use the verifier which is built into this, kind of MIP scheme. So, and you can verify like, placeholder proofs, or like if you wrap the verification into placeholder proof of like some Stark or like whatever, like some other Plonkish proof system, like Plonky 2, Plonky 3, whatever there is. If you wrap it into like placeholder verification, you can use it natively again, just as a covenant, like as just one opcode, like you can imagine like as a one covenant, right? It's similar to the functionality which you could have got if you introduced opstart verify or like opzkp verify, something like this. Or you can emulate via pipes basically some kind of opcodes which are just missing for native-ish proof system verification on Bitcoin, similar to the way how Starkware did it. So like they kind of like relying on this idea that hey, opcat is gonna happen. So we want to introduce like a specific modification of Starks so they could be kind of fit into like native like kind of Bitcoin restrictions in terms of what you can compute in there. And so basically you can emulate those missing opcodes via pipes like cat or like opmule or something like this, like set them up for like all the developers to use that, for basically whatever, like just community to use that, right? And then use it yourself as a part of the overall process. It's like, so basically there are two ways to do this, like, just to recap. The first way is you can put in the whole verification into a single pipe, or you can do the verification over multiple smaller pipes. So what you're talking about is basically that scenario which I described when you can do verification over multiple smaller pipes. So that means you got to emulate cat if we're going the way, for example, Starkware went, or you gotta like emulate Opmule and like build the verification on top of that. Like somehow multi-round, most probably you will be required to just like verify like commitments in multi-rounds, and that's going to be like whatever, not really fast and maybe not really performant. It's expensive. Like on Bitcoin, you would require like to pay a shitload of it for it, but it kind of will use these more widespread, more commonly used pipes than if you define just one large, enormously fucking large pipe for just the verification, itself. So it's a choice of which application. It's a choice of each particular application, which kind of pipe to use. It's like you want to build it like on top of like multiple smaller pipes, or you want to like just define one big ass pipe to define the whole verification in there. So yeah.
Which is another topic, which is of Bitcoin's block size, pricing the data, buying the block
Yeah.
space to post those
Yes.
pipes. And again, these pipes are put into like inscription envelope type structures, data blobs, and then decrypted to produce transactions, right?
Yes. Yeah.
Okay, I think that was a pretty good like explanation of like how the pipes fit together.
Okay. We accomplished the task.
Yeah, we did. I think I understand it a little bit better now. Let's get into this idea that you have to set up a pipe. Like
Yeah.
this is the catch. Like you can't just
Yeah.
do this. This is what we have not figured out, which is like when we don't have these opcodes, in order to simulate the opcodes, we have to have a one-time setup
Yeah.
to create these
Basically, yes.
pipes. Explain this
So
to me.
let's go for it.
Okay.
Yes, it's like again, there is always a little bit of a catch, but I guess that's like the least intrusive or like the least invasive catch we kind of could come up with. It's like, I guess, let's say it this way, that's pretty much the same catch as like people assume is fine. Like for example, when they do trusted setups for like proof systems. So it's basically one event assumption. Like if just one of like participants of the initial setup, which is supposed to like generate like collectively the key to be encrypted in there.
Yeah, a single honest actor is all that is needed. So among all the
Yes.
participants, if one of them is honest, then it's
Yes.
trust. Then we can
Yes.
trust the proof. Yeah.
Yes. 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 So basically, that's the thing, and you gotta arrange this collective DKG ceremony like in the very beginning, so you could produce basically like collective understanding of which kind of key are we encrypting in there. And once you do all of that, if one participant behaves honestly, you're good. You can encrypt that key which you kind of all produced collectively. If there is like enough of participants in there, or like if for example we go to like certain whatever like miners or something, and we just ask them to participate in this, because like dude, if we don't trust miners, like who do we trust? All right. So
And then all you need is one
yes.
miner who you don't trust to go and spend all the
Yeah.
Bitcoin. Otherwise, yeah.
Yeah. Yeah. If at least one participant is good, you're good. It's like you can go for it. So that's like the catch. I mean, I guess it's kind of all over, like, just crypto scene in general. People kind of consider that it's fine. So it is kind of fine. So I guess up to you guys to decide like if it's fine or not, right? It's just how it works.
Well, I mean, all other types of like Bitcoin scaling rely on various elements of trusted federations or InnoVin type actors. BitVM even like still requires a trust like an honest actor, as far as I know. So
Yeah.
Okay, so when we decrypt this pipe, we can only decrypt, I guess theoretically, and we can only decrypt and produce transactions which would otherwise emulate a covenant.
A signature
Okay,
over
yeah,
it's like a signature over whatever you has put as an input data into the predicate executed over the ciphertext. So yeah, Schnorr signature basically.
gotcha. Okay, so then yeah, could you talk me through the process if you can of like producing that signature? How do I use the pipe? How do I actually receive the ciphertext and decryption key? And how does that talk me through the process of that, of decrypting the pipe to then producing the transaction?
Okay, so let's go for it. So basically, just like every predicate encryption, like functional encryption scheme, it's like you at first set up like the master key for like which you use for encrypted stuff. All right, you gotta also like produce besides that like decryption keys for people who are gonna be like attempting to decrypt certain pieces, whatever like they want to decrypt. All right, so once you get that ciphertext done, it's like if people decide to store it like right on Bitcoin, like in Taproot transaction, okay, cool. It's like you inscribe it in there. It's like you found this ciphertext. You're like, okay, cool. It's like I got the decryption key like from somewhere again, maybe from Taproot transactions. Some way you kind of decided to store it as an ordinal. Like, goddamn it, dude! Like for some reason you decided to store like the decryption key as an ordinal. I have no idea why.
Someone's gonna do it. You just have to accept it. And they're going to be trading these things for insane
Yes.
values someday. Yes.
There might be, yeah. So and basically you retrieve that from somewhere. All right, it's like preferably from somewhere like on Bitcoin. So you bootstrap the like whatever, like just binary or something like software, piece of software which processes this as an input, and along that you provide as an input to this whatever like piece of software, whatever, a piece of code. You provide as an input a proof of a computation you want to prove is valid, and you want to do the signature over at the end of the day, like not like over the proof itself, but like over the data you're trying to prove that computation over was done correctly, right? So it's already whatever. So
Yeah.
you provide a proof in there, like of certain computation being done. So it's like you verify that proof like during the it's like if you start multiplying basically the ciphertext and like like the key and like the plain text you put in as like basically a DPVS, like just to like you start multiplying two elements of like two vector spaces to produce like pairing product result. So and basically after that it's like you like during this process is like if a proof system verification is linearizable, is expressible the way so it could be done during this multiplication happening. It's like you get the proof verified, and like in the same time, like Schnorr signature. It's like why it's Schnorr signature, why it's not something else. It's like you. I mean, basically, okay. Well, you could potentially like do that with like ECDSA, right? It's like I've seen like for example, as you mentioned, Jeremy in his write up like a little bit earlier, he supposed this to happen like over CDSA. Due to it doesn't work over CDSA. Like okay, well it works, but it works pretty shitty. So preferably Schnorr. So, and at the same time, you can linearize, again, tricky, but you can, a Schnorr signature production process into this like pairing computation process. So in the end of the day, like with this input you've put through this binary like piece of code, whatever, you get a signature over the data you have supplied as an input in here as well. If you have supplied, like for example, a valid Bitcoin transaction and like it has passed all the checks and like all the computations needed and everything like over it, you're good. It's like you can use this signature over a transaction. Like you can just submit this transaction like as like to Bitcoin because you have a signature for it already. So it's kind of like again like off-chain process, which either yields you a signature or like not. So that's what it is.
That is something I will have to go back and listen to a few times to like to try to wrap my
Yeah.
head around. But at least you explained it. Maybe a listener can like wrap their heads around it better. So I want to pull pretty far back here and
Okay.
just there's someone sawing outside, but whatever. Um, um, well, I want to pull really far back here because you've designed a scheme which works without a soft fork. And just because this is a topic of our conference and kind of a personal interest of mine, I just want to get your thoughts on soft forks in general. Um, you know, what do you think about the likelihood of future Bitcoin soft forks? What's your thinking there?
I mean, look, it's like let's start with one thing. It's like I don't think that at this point, I don't think that at this point, just hard forks. You can't do hard fork with Bitcoin like at this point. I don't believe you can. It's like basically because like again, the hardness of this process, like the complexity of this process, depends on how large of a cluster you have, how non-deterministic it is, and like Bitcoin is kind of like on this, very maybe like not like very like far edge of like being the most non-deterministic and like the most decentralized, but like it is like very decentralized and like kind of very very like the replication packet leader next cluster leader choice is always non-deterministic. So at this point, just it's like really complicated to go over and like make everybody upgrade the software to like do something really new, and that's pretty much the same like with soft forks. To be honest, it's like it might not require like that kind of hard social consensus that hey we're going to change the behavior. So because everybody's like afraid of screwing something up. It's like with soft fork, you kind of are not afraid to screw something up. I mean, at least kind of, right? Because well, you still kind of upgrade in software. I mean, there still can be a bug or something, and at the end of the day, you end up with like pretty much the same risk. So, and like just going around all those people, like trying to convince them that hey, it's like you got to do it, is like hard. And like I know Will tried to do that kind of stuff, tried to pull off that kind of stuff. I know with some kind of chosen group of miners to convince them to upgrade to cat compatible implementation. As far as I know, it's like tell me if I'm wrong. I might be wrong in here.
I
So
I don't think I'm not Blockspace will, but there have been people who've considered this.
okay, okay.
Yeah.
Okay, it's like I've just seen it. I've just seen it somewhere, like on Twitter, and like as far as I remember, it was probably like Will, but
Yeah,
whatever. Yeah,
I mean, like the Taproot Wizards are a great example. Like they're if I
yeah.
can put
Also,
words in their mouth, like they tried to like jumpstart the conversation, and it looks like they successfully did jumpstart. In our case, at Blockspace, we're trying to put a conference together where we're like pro productive discussion towards a software, but trying not to like serve anything specific up, just because like this has been a
too
fraught
political.
process. Yeah, this has been a fraught process for a long time, but like
Yeah,
post ordinals, like there's something different in the water. It's brought you back to Bitcoin working on stuff. We see this trend happening many places,
yeah.
and I see like the Bitcoin developer the technical community is having a bit of a renaissance right now. It seems. What are your thoughts about the current state of Bitcoin technical and developer discussion?
Well, it's like let's say this way. There is this still like old memory from like back from 2016 or something that we kind of there was this feeling that we kind of tried everything we could, and like at that point, like back in 2016, it was actually that way. I would say because I mean not that many proof systems were that well developed, so you could incorporate them into something this kind of all the witness encryption, all the predicate encryption, like functional encryption, all that stuff was pretty novel as well. I mean, it's still kind of pretty novel as well. So it was just not there. So at that point, people kind of abandoned that, just even attempts. So everybody was like, okay, well, just keep it, like count it and see it go up. That's it. So that's all people wanted to do. So basically, that's the thing. It's like I would say, it's like thanks to like experiments, for example, like over in Ethereum and like to a lot of like experiments like over like in Solana and everybody else. It's like it's quite a lot of technical progress was made in terms of like what you can do. It's like what you can do with proof systems, what you can do like with cryptographic primitives and everything. So it became possible to like apply back all of that progress to what we have like as first and like the oldest, as you said, cluster
Yeah.
out there in the industry. And so now it kind of just kind of all goes back to Bitcoin in terms of like what can be ported from the rest of the industry back to Bitcoin, so it could be applied in there. So yeah, I mean, it's like it's like it's going to be interesting. It's going to be
Yeah.
interesting. It's like people are going to start bringing these things back.
Yeah. I heard Rindell from the Taproot Wizard say something like, there was so much money, which it could be misleading to like look at a lot of what are many of which might be unsuccessful experiments or attempts to do things on Ethereum or various proof systems, and to hand wave all those away. But what they've done is accelerate and put a lot of financial incentive to
Yes,
do very interesting, groundbreaking research on
that is true.
their knowledge.
That
And
is
I
true.
think I feel this is very underappreciated. And I look at Bitcoin and I think a lot of us who see the directionality is like are very envious. We want that type of researcher like yourself to come try this on Bitcoin, see what we can accomplish. And if we can apply any of these interesting, breakthroughs, then so be it. Isn't that the whole pitch? Like, a lot of us Bitcoiners say, very hardcore Bitcoiners say Ethereum is the test net, and I look and I say, well, then treat it like one. Bring the successful innovations back here. So, yeah,
Well, it's like I wouldn't say it's like I wouldn't call like other protocols like a testnet for something or
exact.
else. It's like
I don't think it's an
yeah,
appropriate.
but
I
like
don't think it's a fair classification.
yeah, I mean it's like there is it's like there is a purpose and there is like like kind of specification for it. It's like specialization of each of them on each particular like things they're good at. It's good. It's like but like yeah, like bringing back all of that. It's like all of those advancements like in terms of just now is I mean seems to be like an interesting idea at least to explore. So that's yeah, I mean it's like that's going to be great if people like start bringing back like Starks and like all these like circuit compilers, these proof systems they've already developed, like all these zkVMs. I mean, dude, it's been a shit show when like zkVMs raised. So and it's still like a shit show.
Yeah,
So a lot of them like pushing forward like very complicated stuff. Like
yeah. Maybe
I
that shit
myself,
show just maybe the shit show carries on Bitcoin. Who knows? Um,
yeah. So
so
like
let's go back to pipes because I wanted towards the end of this at least point towards implementation. You
mhm.
say that you guys are working on implementation. I don't know what you can say on this, but talk me through what this might look like.
I mean, okay, look, it's like the implementation itself, just like the concept itself, is basically, it serves the purpose of people, just to take a look at it, to evaluate if that's like practical or not. It's like that just to throw, like vegetables at me like on stage. So you will have like a very good chance to do that if you want to. It's like just some like very very old like mushy ones so they could
Yeah,
push
some
all
old
over the place.
tomatoes. Yeah, I get it.
Yeah. So it's like that's the purpose of this like overall exercise like in the research. So the first implementation, I mean, obviously it's going to be like more like a reference implementation. It's like I well I can't guarantee that it's going to be like the fastest one or something, but it's like
Yeah,
it's
so like what kind of I one of the big challenges is like how efficient is this? I think I saw some people ask like, okay, you can do a proof system on Bitcoin. Is it feasible?
yeah.
Um, is
Okay,
it
I
feasible
see. I see where this is coming
from a
from.
Blockspace user standpoint?
Mhm.
I don't know if you're able to make any qualifications or valuations, but like, what's your thought about this?
Okay, I see what you're saying. I see where this is coming from. Let's go for it. So, like, if things are feasible in general, right? So, like, the way if, for example, you use, like, okay, well, first of all, like pipes, if you, for example, wrap the whole ZKP verification into the pipe itself, or like you do some kind of like application specific covenant which expresses like the whole world for you, I don't know, like a shit ton of stuff. If for some
Yeah.
reason you decided to, if for some reason you decided to define, to design a covenant which expresses, I don't know how some Chinese boy did something like out there, whatever. Sort of like,
Yeah, Waking did a yeah, I think he did a start verification. Yeah.
oh, dude, I wasn't talking about it that way. I was
Oh.
just trying to invent some random fact. I wasn't talking about Weekend. Weekend, if you're listening to this, like, no, it wasn't about you. But like, I give you all the credit.
We
I
love
give you
Waking.
all the credit.
He's gonna have to fight you it up next. I'm just kidding.
It's like I give you all the credit for implementing like this circle start verifier using Opcat like on like Bitcoin Signet like run by Starkware.
Yeah.
All yours, all
Yeah.
yours. It wasn't about you, sorry. So okay, getting back to this. So if you for some reason define like a big ass covenant, so you don't really have any cost on for verifying it on Bitcoin itself. It's just a signature for a transaction. So that's like what it is. In the same time, there is always this like if it's feasible, if it's like doable like at all, if it's like practical, because quite a lot of people are like, okay, well if it's like practical at all. So there are nuances because like traditionally, if you pick like a functional encryption scheme for general purpose circuits, you end up with a necessity for like indistinguishable obfuscation, which means you gotta make the circuit so complicated that trying to understand what the hell the circuit encodes becomes more complex than just brute forcing all the possible like options, if you can, all the possible options like inputs and outputs like of it. So that makes by definition the whole thing so impractical, like so infeasible. Just forget it. Just never gonna make it. All right. In the same time, like the whole Pipes paper is about how do you try to make it at least a little bit more practical how do you avoid indistinguishable obfuscation, and like how do you express it's like inside the pipe itself computations maybe like inside the inner predicate encryption like scheme itself computations maybe not very general, not like a generic purpose, but some more structured computations, more specialized computations which can fit what we can do without the general purpose with indistinguishable obfuscation functional encryption. So that means, basically that's like the attempt to basically make the whole concept more practical, because as I said, the idea is pretty old. Like it's like really one of the oldest tricks in the book. So the idea is pretty old. It's like this is just an attempt to make it more practical. So how practical it's going to be? I mean, the only thing I can say is that it's going to be more practical than indistinguishable obfuscation, because like indistinguishable obfuscation, like I've seen experiments out there like on GitHub. Somebody have implemented like a witness encryption scheme with indistinguishable obfuscation over multilinear maps. It took like hours to encrypt a private key, like a Bitcoin private key in there, like literally hours on like quite a big ass server. So it's impractical. It's like indistinguishable obfuscation is impractical. So like yeah, like it's gonna be better than indistinguishable obfuscation. That's all I can say right now, right? Everything else we will see that when the implementation's like out there because we're experimenting on that. So yeah.
Got you. Well, I feel like I've at least pulled some interesting uh insights from this, and I feel like I understand a little bit better. Um what I'll just throw a big question to you.
All right.
What excites you about Bitcoin right now? Beyond what you're working on immediately with pipes and under allocate, what do you think is interesting about Bitcoin today?
It's like I guess the most interesting and like maybe not like paradox, but it's a paradox, but it works. It's is how this whole like community, this like kind of Bitcoin, like this overall like just Bitcoiners, right? It's like have managed to maintain this big ass meme. Like no matter it's like really complicated, no matter it's like really complicated to do anything like it's like the Bitcoin because it's very political. You gotta like agree with multiple parties, and like it's just huge in terms of like amount of miners, amount like of nodes and everything. So no matter it's like really complicated to do anything, people have managed to preserve and like to basically to keep that meme growing. It's like up to that point that in fact it became almost like a planetary scale meme at this point. It's like everybody else like in crypto tries to make it like because of functionality, because of like what you can do. It's like there's like it's like all this complicated like balance, all this complicated dance on like what you make on fees. It's like how do you maintain like the sustainability of the protocol? It's like what the validators will earn and everything. What amazes me like with Bitcoin actually is like how people manage to maintain and like grow this just big ass meme, not caring about like anything else. Just like just It's just so.
That's something poetic about it, that, you are as far in the weeds on cryptography and on the edge of, research and proof systems and everything, and yet you pull back and you see Bitcoin as it's got rules and math and shit, but it's just a
Yeah,
big meme.
I
Uh,
mean,
it
and they're like, and the fact is, like, at this point in time, I think you can't do anything with that meme. I mean, not like in terms of functionality, but it's like, it's here. It's here. It's gonna stay like that huge. It's like, just everybody like has this in their heads, and that's amazing. It's like how over the years people still manage to maintain like, like that relevant, interesting, and like more, it's like much larger than anything else like in crypto in the end of the day. So that's something. That's something which um I'm really amazed by.
I think that's a great place to end it. Any final thoughts, Misha? I really enjoyed this conversation.
Uh, I don't know, like come throw vegetables at me, I guess.
Yeah, get your vegetables. Make sure you go check out Allocant social media and website. Misha on where's like the best where do you publicly communicate, Misha? Is it Twitter? Is it through the blog?
I mean, I do reply on Twitter like quite often. It's like I don't often post on Twitter, but like I do reply quite often in there. So like, feel free. I'm out there.
Go throw metaphorical vegetables at him on Twitter.
Yeah.
And and they'll be throwing vegetables at me too, for even daring to entertain such interesting ideas as this. So, anyway, Misha, thank you so much for coming on Bitcoin Season 2.
Yeah.
I really appreciate it, and I will see you in person in
Yep.
Boston on November 9th for Op Next.
Yep.
Catch you later.